Okay, so thanks everyone for coming today. My name is Olaf Alders, Alders on CPAN, and today I'm going to be talking about testing with GitHub Actions. So the plan for today is I will talk about GitHub workflows and actions, and Mark Fowler will show us how to do a lot of the same things with CircleCI. So when he saw that my talk was on the schedule, he reached out to me and said, "Oh, I'm sure I can do all these things with CircleCI." And I said, "Sure, why don't you put some slides together?" And so that actually ends up being really helpful for me. So just to make sure we're all on the same page, I just want to define what the actions and workflows actually are. So these are both components that you can use as part of your CI process. So I'm just going to move something here. Okay. So what is CI actually? Continuous integration. So it's the practice of automating the integration of code changes into a software project. It's also sort of comprised of automatic tools that assert that your new code's correctness, your new code is correct before integration. That's just something that I grabbed off the Atlassian site. Basically, it's just a way for you to do certain things in an automated process, just to make sure things are as you think they are, before you merge code or do various different things. So, but just to point out, the CPAN testers is not CI. You shouldn't confuse the two things. It's not a replacement, but it's sort of complementary to it. Maybe part of your release process to CPAN, but it's likely not part of your automated build process unless you're doing some really crazy stuff. So some practical examples of what or when CI might happen would be on when you push code to a branch. You might want to run your test suite just to make sure everything's as you think it is. You might want to lint your code just to check it for correctness. You might want to use a tidier to check your code for untidiness, or check somebody else's code for untidiness as you're getting it. On a merge, you might want to do sort of similar things. You might want to run the tests again that you ran on the push. You might want to create, say, a new Docker image, push it to Docker Hub. You might want to send a notification to Slack or to IRC. You might want to send email. There's lots of things you can do. And when you look at GitHub, there are sort of lots of different things that you can do just to trigger the CI. You might want to run something when a tag gets pushed, when someone closes an issue, when a pull request gets created, when someone edits a wiki page, when a repository gets forked, when a label gets added to an issue. You can even run processes when somebody stars your repository to say they're watching it. And there's too many to list, so I've referenced the page where you can go and look them up. So this brings us to sort of actions versus workflows. And in the GitHub literature, they kind of get used interchangeably. So we're just going to simplify them for today. Let's not assume my interpretation is 100% correct, but it'll just be useful enough for this conversation. So the GitHub actions are a couple things. The first thing it's just a name for a product, and the product is something that GitHub makes available to you so that you can run workflows on your repository. Just things you can incorporate into your software development lifecycle. Now, actions are also individual tasks that you can combine to create jobs, to customize a workflow. You can create actions that you can share with other people. You can use other people's actions. They're kind of this modular thing. So it's the name for the product, but it's also the name for specific parts of the product that you can use. Now, what are the workflows? Well, the workflows are really a way to put actions together. Workflow is an automated process that you can configure. You can configure it with one or more YAML files, and those will just live in a .github/workflows directory. And your workflows can have descriptive names. They just need to end with a YAML extension. They need to live in the right spot, and you need to say what actions will trigger your workflows. So just to wrap that part up, if we were going to think of this in terms of Perl, the actions, which are the reusable bits, would be kind of like modules. The workflows, which you need to create on a per repository basis, are more like scripts. And the workflows can include actions, but they don't have to. Just in the same way that your Perl script could include some modules, but there's no reason that it would have to. Now, the specs you're going to be working with on GitHub, you got a 2-core CPU, 7 gigs of RAM, 14 gigs of SSD, and you can run 20 concurrent jobs. If you're dealing with macOS, then you can only really run 5 at the same time. So that's something to consider, but you've got the 20 basically in general, especially for Linux jobs. If you're paying, you can get more. but this is sort of the starting scenario. The runners that you have available to you are Windows Server 2019, 3 versions of Ubuntu. Ubuntu 20.4 is basically in preview right now. So if you ask for Ubuntu latest, you're going to get 18.04, and then macOS 10.15 is what you get on the Macs. Self-hosted is also an option, but that's outside the scope of this talk. But it's also something to consider if the specs or the environments here don't meet your needs. Now, if you need Perl, it only comes pre-installed on Windows. That's a 5.30.2. So if you want to test something on a bunch of different versions of Perl on a bunch of different operating systems, it's not really pre-configured for your needs. So there are some things you'll need to do, and that's what we're going to talk about today. Now, we've defined what a workflow is, but what does it actually look like? We're going to start with a very simple example that runs on one single trigger. Now, let's say we have some shell scripts and we want to run a linter on them. So we'll just create a file in .github/workflows. We'll call it shellcheck.yaml. You can really call it whatever you want. As far as the on goes, this here dictates that this code will run when something gets pushed to the repository. We just need to give our workflow a name. We'll call it lint scripts in this case. And now we can dictate a set of jobs to run. And each job has an ID, can be just some arbitrary name. It needs to be unique. We'll just call it shell check job because that's descriptive. You can give jobs names as well if you like. And you need to say what it's going to run on. In this case, we just want to say the latest version of Ubuntu, which we decided was version 18. So now we can dictate the steps that are included in the workflow. And this workflow is very simple, and it just has 2 steps. The first step is an action, and it's the checkout action. And what the checkout action does is basically it just checks out your repository into the working repository on the VM. And that's all that it does. It can do more, and it's highly configurable, so you might want to check that out. But in this case, when we're saying checkout at master, that's actually saying which version of the checkout action to get, not which version of your repository. It's just basically going to be, if you're in a branch, it'll get the latest commit on that branch, put it into a working directory for you. The second action that we want to run is just to lint the bash scripts, because that's what we're here for. And for that, we're going to use this particular action here. And that really is it. This action has configuration parameters as well, but in this case, it's just going to look in a bin directory to see if we have some shell scripts. It so happens that we do in this case, so we're all set to go. Now, what if we want to run this on more conditions? We want to run it on push. We can here also add a run on pull requests, and we can schedule a cron. So initially, when we just said on push, this is what it meant. It meant push on each branch, and you can see that you can now configure patterns for which branches you would want this to run on a push condition. You can do the same thing for pull requests. The cron scheduling is kind of nice. You can do the same kind of thing with Travis through the UI. I'm not sure if there's another way to configure it, but it's nice to have this here just in the configuration file itself, and you'll see that we'll use it later on. Now, our final file is going to look something like this. That's just the way it is all put together. This is an example that you could just copy and paste and run on your own. I've already added a link to the slides in the talk. So if you're looking for actual examples to get up and running with, you could just grab those, copy paste. I'll have some links that you can follow as well to working workflows that I've got sort of in the wild right now that you can test against. So I've got this recurring cough I've had for a few months. It's not pandemic related, but it's going to interfere with this talk a little bit. I apologize for that. So the most useful action that, or the one you will probably use the most, is just called checkout, and we've already seen it in use here. And as I think I said, you can add parameters to it, so you don't have to just check out your repository. You could check out somebody else's repository. You could check out repositories side by side. You could check out one repository nested inside of another one. There's all sorts of options. And you should check those out as well. And so I think that if you are going to use GitHub, you should get familiar with this, because this is something you'll be using a lot. Now, the way you invoke actions is helpful to know about too. The actions are tagged, and you're basically saying which tag or other thing you're interested in, what version of the action. So for example, in this case, you're saying, let's get the checkout action, whatever the latest version of tag in version 1 is, I'd like that. Now, if you want a specific tag, you can ask for a patch release. If you want a specific branch, you can ask for master or whatever the branch name is. If you like to live dangerously, this is a way to go. Just keep in mind that things could break at any point. I've been using master for the checkouts. I think it's basically been fine, but keep that in mind. Or you can just use a particular SHA as well if you're really picky. One thing also to keep in mind with the actions is this actions here, this is actually the username and this is the name of the repository. So it just so happens that there was a username that GitHub has that's called actions, and that's where the GitHub keeps its actions. You can publish your own actions at your own repository URLs. There is a list of awesome actions. It's quite a big list. I'm not going to vouch for how curated it is, but it's a good starting point just to get an idea of what things are available for you to use. So let's go back to our first example. And this is, we've just got the push condition here. We don't have the other ones. But what if we actually, we've done the linting. What if we want to test our bash script? So there's bats, that's a bash testing framework, and we could use that. And we just need to add additional run scripts in order to be able to use bats. So there are, there's a bunch of different ways we can do this, but this is a good way for us to examine how run steps get used in the GitHub workflows. So we're just adding an additional step here. We've given it a name, and then we've just given it basically a command that it's going to run. We're just going to try and install it using npm. Now, in order to do this, this does make the assumption that npm is available. There are ways that you could recover from failure, and that is by checking for the success or failure of the previous step. And so in this case, we can say if the previous step failed, let's actually just try and grab bats from its repository and run an installation that way. And the conditions you can check for are success, failure, canceled, and always. And always is what it implies. But those are sort of good things to keep in mind. It's a little bit easier to work with this than some of the ways that Travis is set up to try and trap error conditions and things like that. So now we've got all this stuff installed. Let's actually just run the test. And then that's, much like running a Perl test, we just run this command. The -t tells us that we want to emit some tap, and then we can just run the test as part of our workflow. Now, GitHub doesn't have a concept of tap or really passing tests. It's just looking for exit codes. So as long as your tests return a 0 exit code, or then you should be fine. So our entire config file now should look like this. This is an example you should be able to copy paste and run. So it's not very big, but it does a number of things. Now, what if we actually wanted to ensure that npm was available to us in an environment? One way we could do that is by using a Docker image. Now you're probably thinking, why wouldn't you just use a Docker image for bats? Why are you getting a Docker image for npm so that you can install bats? And the answer to that is the last official Docker image with bats was a couple years ago. We want to have something more recent. So I just do a search on Docker Hub, and I find there is a node image here based on Buster Slim. And so just above the steps in the configuration, we'll just explicitly say which kind of container image we want. And that's by default going to check on Docker Hub and download this. So now with these two extra lines here, that's what our configuration looks like. And in this case, now we should be assured that npm is available because we know that it's it's in this container. Or do we know? This is an assumption we make. I think it's a fairly safe assumption, but what if we actually want to check that? We can check it by running the workflow, but we can also check it by just poking around in the Docker container. So one of the neat things about Docker is that you can just spin up a container on command just by knowing the name of the image. So in this case, it would be docker run -it, right here, this command right here. We're giving it the name of the image, and then we're also saying, you know what, when you spin up the container, just give me a bash prompt. That's what I want. And it is helpful to specify that because it's not always a safe assumption to think that when you open up an image, you're going to end up in a bash prompt. So we can check to see what the version of bash is now that we're logged in. And we can also just test out running npm install, and we can see that that is successful on this container. So, so we're all set. And just recap on the Docker run flags. The IT basically gives you an interactive terminal. And the RM tells Docker to clean up after itself, so you don't have a lot of extra stuff hanging around on your file system. So now, if that was too tedious for you, if you say, Olaf, that seems like a lot of work, I'm not interested in doing that, can I just run the workflows locally? I say, yes, actually you can, with a fairly long list of caveats, but in this case you can. So there's a project called Act, and you can install it, run it inside the top level of your repository, and it will run your workflows for you locally. So it would look something like this. You can see there's a fair amount of output, lots of fancy emojis for you. And on my laptop, it took about 4 seconds. Now that is because this is a subsequent run. I have all the Docker images that I needed, but you can see that you can get a fairly short feedback loop on your workflows under the right conditions. You can also use Act to get visualizations of the jobs in your workflow. This one, fairly unimpressive, but also accurate. We just have the one job, which is test job. Now, what are the bad parts about Act? So artifacts aren't yet supported. Now, we haven't talked about artifacts yet, but we will. And so basically, like a build artifact is something that's left over after you run your build, and maybe some new file that gets created, and you may want to do something with it, like save it. And there's an action, upload artifact, that allows you to upload your artifacts to somewhere, I don't know where, but it doesn't actually work with Act. So if you're using that, you may need to comment that out. Also, if you have later logic that also wants to download these artifacts from we don't know where, then you probably have to comment that out as well. The checkout action, which we already talked about being so popular, it doesn't accept any args under Act. So if you are doing something other than just checking out your code, you will have a problem there. And so I've only gotten this working on the initial, the primary build step. That's been good enough for my needs. It's sort of helped me sort out a lot of things without having to go to wait for GitHub to get back to me. But it's definitely not perfect, and it may not detect some brokenness in your workflow configs. It doesn't do maybe the validation that GitHub does. Okay, so you're saying, Olaf, you've told me a lot about Bash. Maybe I don't really care about that. How about Perl? So that Perl is what we're here to talk about. Now, there are different images you can choose for Perl. You can get the official Perl builds, which are provided by Docker, and they're actually quite fast and staying up to date. 5.32 has been available for, I think, a couple days now. There are some slim builds, which are smaller images, but you might find that unless you have very basic needs, those might not be enough for you. You can definitely try them out, but you may find yourself falling back to the official Perl builds. Now, if you like a really big hammer, then the Perl tester Perl Docker images may be for you, and that's a project that Nico and I have been working on together. Now, what this does is it comes preloaded with Zilla, a bunch of Zilla plugins, Manila as well, and a bunch of test and development modules that you probably need anyway when you're building and testing CPAN distributions. So what you get here is it saves you the download and install time. You'd normally need to do this on demand. We make the builds nightly. So we talked about that cron configuration in the workflow. We have one in this case to build these Docker images every night. And we have some helper shell scripts in there to reduce some of the build and test boilerplate. If you don't have those, the GitHub workflows tend to be quite long. So the bad parts are, this is not going to help you on macOS and Windows because it is Docker. You might miss some undeclared dependencies if you're only testing on these images because there's already so much that's there. And you may just assume that you don't need to declare a dependency on something, but that might not actually be the case. And also, because we update the dependencies nightly, you're going to be getting latest versions from CPAN. So you might not catch issues that come from older versions of modules, but you may actually end up catching issues that come from newer versions. So you might want to work around this, especially if you have a regression test for a bug that's in some other older module. Now, I did want to talk about speed. One thing that sort of got me interested in this over Travis was that it's just quite fast working with the GitHub workflows. But you can be even faster than the defaults. One thing you can do is use these Perl tester images to do your building and testing with. There is a caching action. I haven't actually used it because with the Perl tester images, I've actually found that's been fast enough for my needs. There are sort of subtle bugs that can come up when you're using your own caches as well. So that's something to be careful of, but that's definitely available to you. When possible, I would say install with CPM rather than CPNM because CPM can install in parallel where CPM- doesn't. So that can actually save you a lot of time, especially if you're installing a lot of dependencies. If your code coverage is bringing you down, you can run that in its own parallel job. If you have a big test suite, running devel cover on it can sometimes really increase the time of the job. So you might want to just split that out to something else. And because we're able to parallelize things, you're not going to take a big hit from that. And then another thing is just to build once and then test many times. One other thing you can do is this kind of crazy thing that Nico does where he checks non-access dependencies into his repo and then uses those. He just told me about it this morning. I'm not even going to talk about it, but I will leave it here if you want to delve into that any further. Okay, so now we talked about building once and testing many times. As far as the initial build goes, this is what a build configuration might look like. So as far as the jobs go, we're going to have a build job. We'll give it a name. We're going to run on Ubuntu. We're going to use our Perl tester container. We are going to use our checkout action like we talked about. And then we're going to run something called auto build and test dist. And that is one of the helper scripts that comes with the image. And it will basically do the right thing with your repository. It's going to get all the latest dependencies. Even if we have dependencies from a nightly build, something might have been installed in the meantime. So we'll get those if we need them. And then you can just set some environment variables on a per step basis. And in this case, we're saying run the author test, run the release test. And oh, by the way, I have a codecov.io token that I have in my GitHub repository secrets. I'd like you to use that to run some code coverage. So to set the secrets, it's just in your repositories. And I think it's actually just settings and secret, and you can go and add a secret. The neat thing about the secrets are that GitHub will jump through a bunch of hoops to try and make sure that your secrets don't end up in any of the log output for anybody else to check, because your build output is public. You do need to be careful how you use your secrets, but they will take steps to make sure that they don't get exposed. And this helper script will, if it detects the correct token, it'll do the right thing. And then once all this is done, we're going to use a new action here, and that is the upload artifact. And so this says you just give it a path to a directory, and then it will upload that directory up. Again, I don't know where, somewhere in the cloud. So we don't have to care about that. And then so to get to these helper scripts, this is basically we're running here with the auto build and test. It's a little bit like the Perl helpers on Travis, where it kind of just does all the things that you normally would need to do. It works fine for a Zilla and Manila distributions right now. And then again, if it detects a code cov token or a coveralls token, it will run a coverage build and it will upload to one or both of those services. Now, we talked about coverage being slow. So what if we just want to add a job specifically for coverage? Well, we can do that. It's not a problem. So this introduces a new keyword, and that keyword is needs. And if you specify needs, that basically says, do not run this job unless the job that it needs has already successfully run to completion. So that means if the build job fails, this coverage job never runs. We're going to run this on the Perl tester image as well. In this case, we're gonna check out. We're gonna use our download artifact action for the first time, and we're just gonna give it the name that we gave to the upload artifact, and then we're just gonna say the path is dot, so just put it into whatever working directory we have. Just make that this directory, and we are also using the checkout action in this case, and only just because of some weirdness around codecov, because it wants to detect that it's inside a Git repository. Otherwise, you wouldn't need this at all. And now we're going to install our dependencies and test, and we've got another helper script for that. That's cpan install dist steps. We can pass it some arguments like with develop that it'll pass on a CPM, and then we're telling it to test the distribution. We've added the code cov token to our environment, so again, it can auto detect that this is actually a coverage build, and that's done. So we've got the build, we've got the coverage job, and now we just want to test this many times. Now, what's kind of neat about the workflows, which you actually can do with Travis as well, is that you can get a build matrix, and the build matrix belongs in under the strategy keyword. And what this does is it constructs a matrix of different variations of variables that you hand to it, so that you can test a lot of things without being really verbose. So in this case, basically, we're going to run through Ubuntu latest, macOS latest, and Windows latest, like all those different environments. And for each of those, we are going to run a job on a specific Perl version. The Perl version probably would be much longer than that, but this is what fits into this slide. You can add additional items to the matrix by using an include keyword, which you can do on Travis as well. And you can also exclude here. So in this case, we're saying, so just do all these things, but if it's Windows, don't do it on 5.10 and don't do it on 5.12. Just for my testing, those have been sort of problematic versions, and I've been happy just not to worry about them and get on with my life. So I just say, like, don't worry about that. But this gives us like a very nice, concise way of testing a lot of things in a lot of places. You will need to use the matrix variables here, and you can use them in a name. You won't get by without specifying matrix OS in the run zone, because we do need to define what our environment is. And this also gives us one more keyword, which is fail fast. And fail fast basically means like that if you're inside a build and a job fails, that's done, just return, forget about it. That is the default, but I wanted to put it here explicitly because it is useful. Sometimes, like, let's say if you're testing stuff on Windows, you might actually want fail fast to be false, because then you can see the test run for every single Perl build on Windows, and you can see, oh, it's maybe just some of them that are failing, not just all of them. Now that we've got our job basically set up, we've got it scaffolded on the operating system, a Perl version that we want. Now we actually need to figure out which steps to be run. And this brings in a very helpful action here called setup Perl, which does, strangely, pretty much what you think it does. And so you just tell it a Perl version, which we've got from the matrix, and it will go and set up that Perl correctly for the operating system that you're on. You can pass it a distribution value as well. This will be ignored on every operating system except for Windows. I would highly recommend just using Strawberry, because that's been sort of less problematic for me in my Windows testing. You can see here, we're also going to download a build artifact, and now we're going to install our dependencies with CPM. Now we can't really use those helper scripts here because they're not already pre-installed here, and we're also running on Windows as well. So Nico has put together this very handy Perl action that says install with CPM. You can give it a bunch of arguments. This is also highly configurable, so I'd suggest checking the docs on that. But it will, you don't even need to have CPM pre-installed, so you can use this wherever you want, and it will just do the right thing. And if you don't want to use CPM, he's got a very similarly named action that uses CPM. And then the last thing we're going to do is just run the tests and set some variables for those tests. The entire config file now is actually too big for me to show you on a slide. So there's just a link there for one that is actually working in the wild, and you can crib from that. Now, if we visualize this build hierarchy, we now see this is actually slightly more interesting, because we can see there's a coverage job and a bunch of matrix jobs, and those all depend on a successful build distribution. Now, what if we actually just wanted to test Linux first? Well, then we could do that. We would just break out Linux from the matrix that we created earlier, and it still needs the build job, but we will just change the matrix to need the Linux job. And then this would sort of be the visualization. So run the build, we'll do the coverage in Linux. If everything's good on Linux, then we'll move to the Windows and Mac machines. And one reason to do that would be you can use the Perl tester images there, but also if GitHub at some point starts using a credit system, it might actually be cheaper to run. It might require less credits to run on Linux than on the other systems, so being less resource intensive. So that might just be a strategy you'd want to employ. Now, if you're looking for a Docker image and it doesn't exist, you can just build your own, and let's very quickly talk about that. Now, this is an example you can just grab from the Docker images that we've been talking about. And basically, all this stuff is familiar to you. These are just the trigger conditions. We've got a matrix here. And then the new part here is this particular action here. And this is just a publish to GitHub action. You need some secrets for credentials. You need to have a Docker file. And then based on that, it will just run your Docker file and do the right thing. The neat thing here is that Docker files do take build arguments. So in this case, we're just passing in an argument to say which version of Perl to create a new image based on. And so that allows us to use one Docker file and create many, many Perl images every evening. So one other thing you could do is spin up a Docker container as a service as part of your test suite. So I was working on a project where I was using the Postal, but it was quite slow. It's faster if you set it up sort of as a microservice. So as a build step here, I set it up with Docker. do a few other things, and then come back, and hopefully that service is ready and responsive at that point, and then I can start using it. So that's just kind of one other neat thing you can do. You could maybe even upload a CPAN file snapshot to a build artifact. One, I think this is the last thing I'm going to cover, is this kind of neat, is that you can use it to manage the labels in your repository. So there's an action here that says all you need to do is create a YAML file that has label names and colors. You can use an exporter to create that. Then you just use this action here, and it will sync up your labels. And this is actually a good demonstration of like a more complex trigger condition. So basically, here it's only on pushes to master, and it's only if this particular file is in the diff. And so, which actually makes sense, because there would be no point in syncing your labels every time you just push some random stuff to GitHub. So you can really kind of narrow down when these things happen. So having said all of that, before I pass it off to Mark, Dave Rolski is doing a talk on Azure tomorrow. So I highly recommend you see that. You may just think, what I've told you is not helpful. Dave's got something for you. So just check that out. I mean, they do slightly different things, but I think it's good to be informed about that. And also there is a Dist Zilla action available on GitHub as well that will let you just run Disa without having installed that as well. And with that, thanks to the organizers, to the sponsors, to Nico for working with me, and to Mark for co-presenting. I will now stop sharing and hand it over to him.
Hello, everyone. Okay, let's hit share screen. And okay. This okay, everyone? Yes. Okay, so hi. Thanks for the introduction. As Olaf said, I'm Mark Fowler. I'm a Perl programmer that's been doing conferences for about 20 years, getting excited about really cool things that everyone's doing. And one of the things I was really excited about was to see these Perl tester images that Olaf was showing, because I recently started working for CircleCI, and I realized that we could use them to make building with Perl really easy. So let's talk about something really important. Let's talk about how I can program Perl with My Little Pony character names. And that's so important that I'm going to upload it to GitHub so the entire world can share. And of course, you know, it's really important, so it needs to be tested. So I'm going to show you how to test that with CircleCI. So this is a CircleCI homepage, and from here we can go and click on sign up, and we start the sign up process. But the sign up process isn't the kind of thing where I go and create a username and a password and some memorable phrases and everything like that. No. I just go over to GitHub, click and authorize it with GitHub, and I'm immediately bounced back to CircleCI, having essentially signed up for this. And now I can pick the organization. Now, if you're like me, you'll have your own organization, you have your work organization, you have all your open source organizations, but this test user only has one organization. So let's click on it, and we get the list of all of the repos, or in this case, just the one, and we can just go and set up the project. And here we are, we're now at the final step of setting up the project. It was that simple. We've just got to define a YAML file, which, as you've seen before, this is a common thing with CI systems. CircleCI makes this simple, though. First of all, it doesn't require you to go off and open up your editor and commit things and get out of it. You can do it straight in the web browser. And if you've got one of the supported languages, you can just go and pick it from the list. Unfortunately, Perl isn't on this list, but it probably will be in a couple of weeks now that I've got all of these cool tools to play with. So let's just go and delete all of this and copy and paste in the 7 lines of YAML we need to build. That's it, just the 7 lines. And now we can just go and click add config. And yeah, it's running and we're done and we're already building. That's all we needed to do. And of course it will succeed and, oh no, it's failed. Yes, of course it's failed. So in my demo, I thought I'd show you what happens when it goes wrong. So we can go and click on the big red button, and then we can see the jobs we've been running. In this case, we've got one job that's failed, and we can see all the steps. So we spun up the environment, we prepared the environment variables, we checked out the code, and we got an error message in our test distribution. So if I scroll down, you can see that I have forgotten to put the abstract in. So my source code is Zilla based. So what we're doing is we're building a distribution, then we're testing it. And one of the things it can't do to build the distribution is it needs that abstract. So let's go over to GitHub on the new shiny interface, which they added like yesterday, and add in abstract here, commit it, and go back to CircleCI. And because we committed it, we pushed something new, a build was automatically triggered, and in this case, it was successful. Huh. Okay, but what if it wasn't that easy? What happens if our output didn't tell us what to immediately go fix? Well, we'd probably have to add more debugging, wouldn't we? And then build something else and then realize we hadn't put enough debugging and add more debugging. That sounds tedious. What can we do if we can't tell it's broken from the logs? Well, we could just log into the CI box and poke around. Yep, you can do that with CircleCI. So you could just go over to the failed job and rerun it. And this time I'm going to rerun the job with SSH. And in this case, I can go down to the new SSH action step here, disclose it, and I've got a command I can copy and paste and just type directly into my terminal. And that will go off and connect to the machine that is running the build, and the machine will wait for us. So let's copy and paste, go in, log straight in. Yes, I want to go in. And now I can start poking around. I can go into my working directory and look around. I can type less and to list the files in there. Well, maybe if I type less and try listing the files, and I get an error message because less isn't on that image. But I can get and install less because, you know, we've got really fast internet connection here. And then I can even do things like, I don't know, run the failed. Oh, I can list the files. Yes, good. I remembered I could do that. And then I can go in and I can start actually running the tests that didn't work. Right, like so. So that didn't even require a username and password. Well, but it is secure. It's because you already gave GitHub a public key that you use to push your code and your commits with. And we use the same public key to detect whether you're allowed to log in or not. Awesome. So to recap, we just set up an entirely new box, a entirely new project on CircleCI without entering a username or password or doing anything other than clicking a few buttons and cutting, pasting 7 lines. And we're even able to log into it when it goes wrong with SSH and work out what's going on. That's pretty awesome, but why not get more advanced? Because, well, I'm going to have to do a little bit of CircleCI terminology real quick. So we've got steps. Steps are the individual things that we were seeing these in previously with what Olaf was talking about, that run an individual shell command or upload an artifact or saves restores to cache. And it's kind of like music. So it's the notes in the music. And they are played by someone. In this case, they're played by a job, a collection of steps that runs on its own virtual machine. And each job you have has its own virtual machine, which is set up from scratch. But these can work together. They're controlled by a workflow. I think workflow has a slightly different meaning to what Olaf was talking about earlier, which is the order that and control of how the jobs are passed together in a pipeline, which is kind of like a performance where it's an actual run of all of your jobs. Oh, that was a bit of terminology. Another funny terminology is orb. Orb is kind of like a module for these YAML files, and it's what enables us to have this very, very short piece of text. So here we're defining what orbs we're using. We're going to use the CircleCI Perl orb, and we're going to give it the Perl namespace. And then down in our job, from our Perl namespace, we're going to run the build job. And that is pretty much it. In fact, there's a whole registry of these things, which is kind of like the CPAN, right? So we've got CircleCI IRC, which notifies to IRC, or we can do the same thing with Slack, or we can upload things to AWS, or we can mess around with Docker, or we can deploy to Heroku, or we can use lots of third-party things like logging to Honeycomb, or using white source to check for vulnerabilities. And I said, there are loads of these things, and they are configurable. So let's just look at our Perl one. In this case, we're just using the build thing. So let's go look at the build job, right? And that has options in it, like enabling code cover. So underneath the skin, underneath the hood, this is using exactly the same kind of Perl tester and convenience scripts Olaf was talking about. In this case, we're enabling code cover. So we go and we add the extra parameter, turn it on, set it to true. And now look, we've got code coverage in our logs, and we've got the link to where this was uploaded, and we can see it. Okay, this being CircleCI, it's a little easier to configure. Like, you don't need to pass a token because CodeCov can use the CircleCI API to go and work out exactly what's going on for you. Anyway, what else can we put in here? Well, we could upload artifacts, I guess. So we can save artifacts, yep. And this adds 2 new steps. We're going to make a tarball, we're going to upload the artifacts. And then if we go look in our artifacts tab, oh, look, we can see them. They're here. We can download artifacts. Or, well, there's a whole bunch of them. What could we do? We could save to workspace. Oh, wait, what's workspace? Let's talk about caching. So the CircleCI supports multiple forms of caching. One kind of caching is the standard caching. So you run a job, you run a job, you run a job, and they take forever because they they have to start from scratch each time. Sometimes you might want to take the output from one job and feed it into the other job so it can avoid having to redo the same thing again and again. And that's standard caching. The other thing that CircleCI supports is workspaces, where it's a place where different jobs can put things in a shared workspace just for that pipeline so that they can communicate to one another. And if you add another pipeline, you run it again, they get a new workspace. Oh, wait, I just started talking about multiple jobs. I better cover that quickly. So look, another job that the CircleCI Perl offers is test Linux. So let's add that next job in there. Test Linux takes something that's in our workspace. This is similar to what Olaf was talking about just previously about uploading to Artifact, but in CircleCI, it's a more streamlined process. You push into the workspace, and then the Perl test Linux pulls it back down, and you can test it on something like Perl 5.10. Oh, and I need to do the same thing where I say, I want to wait until Perl build is finished before I start running it so they don't run at the same time. And then in our GUI, it looks like this. We've got our Perl build. We can go over and see that the Perl test Linux is waiting on it. Yeah, and again, we don't want to just test on 5.10, we want to test on everything. So again, a matrix is the way forward. And we can add that really simply with CircleCI by just saying a matrix transformation like so. And now we can see that we've got this kind of fan out system where we run the one job and it fans out and then runs all of the other test Linux jobs. So how did it do that? Well, let's go over here and look at the configuration file, which is terribly unexciting because I just showed it to you, but we can also go and see the compiled version of this, which is very long, which is is the version of the config file, which all the orbs have been expanded and all of the things that have been needed to be duplicated out. So essentially what this matrix confirmation is doing is turning this simple config into a multi-step process, producing all of our jobs. But now we've looked underneath behind the curtain, as it were, to see what's going on. We can start seeing what else this was doing. This is the Perl build job is in fact just really this. It's picking a Docker image, the latest Perl tester one. It's running some steps against it. It's checking out code. It's running a command. It's persisting things to a workspace. In fact, it's not that hard to write one of these things from scratch. So here is a standalone piece of YAML that will run. It's the simplest possible thing I could think of. So we can see that we declare a job called build, which has which runs a Docker image, and it has some steps in it to check out and run. And that's simple. You may notice there's no workflow anymore in this. That's because CircleCI also supplies a default workflow, which is to build whatever is in the build job. And we see you're using a run command, and these are flexible. You can just run a single command. You could say, I prefer it to have a name. You could say, I'd like to run multiple commands. You can say, I'd like to embed a Perl script. These are all things that are really simple and straightforward to do. And you can see I can actually specify where I'm going to run it, what image I'm going to run it on Docker, but I'm not limited to Docker. I can run it on a Linux machine image. I can run it on Windows. I can run it on macOS X. I have multiple choices here. And I can even use CircleCI to build Docker images. In fact, CircleCI is really good at building Docker images. And the reason for that is it supports Docker layer caching. So here's a Docker file. This is the Docker file actually to build the CI Perl tester helper-based Perl tester image. So what we do is we step through these and build up file system layers. So let's say we download a layer from Docker Hub. Each command we execute, we build up more layers, and then finally we have a scratch layer on top when we execute the command. And each of these have files in them. And these files can be kind of built with an overlay file system. So it seems like you're just running in one layer, but actually you've got all of these layers. What if you change one of these files, like the red spinny one there? Well, that layer's toast. It's no good anymore. We have to rebuild it. And the layers above, yep, they're toast too. So we need to rebuild all of those layers. But by rebuilding those layers, we have a new system. But these two layers at the bottom did not get rebuilt on a normal machine. And this is really important if that layer near the bottom took an hour to build. So what we want to do is cache those and redo it and reuse them, which is what Docker will do on your desktop machine. But on a CI system where you throw away the entire VM every time, oh, they go, and you have to rebuild everything from scratch. Unless you're using Docker layer caching, where we resurrect those layers and put them back where they're supposed to be. And we only have to spend the time building what we need to. Oh, secrets. Olaf mentioned using secrets. In CircleCI, we need to, when we want to pass a secret, like the coveralls token, for example, we go and put it in an environment variable. So here's an environment variable. It's really straightforward. I'm in the config for my project. I can go click and I just add an environment variable. Yeah, no, copy, paste, coveralls token should be this. And when I save it, it's hidden from view anymore. I can't access it again. It's secret. And when I build with it, you know, you'll see that you can see here coveralls repo token is obfuscated. I can't see it again. But it still works. I still have 100% code coverage, which is a total excuse to use this slide. So I've been talking very quickly because I don't have much time to cover this, but I wanted to cover one last thing before I finish speaking, which is the important thing, pricing. How much does this cost you? Well, you saw when I signed up, I wasn't asked for a credit card number or anything like that. That's because CircleCI gives you free credits. So CircleCI uses a credit system. It gives you 2,500 credits free per month, which is about 4 hours of build time. And that's for anything you want. That's for private repositories, public repositories, the whole enchilada. But for open source repositories, that is anything on GitHub where you do not, where you have marked it public, you get about 4 weeks worth of build time per month, which is, you know, like you can build pretty much every waking hour for free. So that's pretty awesome. But should you want to power up and spend more money, you can, of course, you know, run more jobs at once, get more CPUs, which allows you to make things go much, much faster. So that is the lightning version of CircleCI. And hopefully I've shown you by running so very quickly through everything, how easy it is to set up with just a web browser and a few clicks. Thank you. So Olaf, we really should have discussed how we're going to end this. You did a nice job thanking everybody before I managed to say anything. So I guess the traditional thing is to say any questions.
Yeah, we have a few minutes and questions for either Olaf or Mark. Please raise your hand, or you can just unmute yourself in Zoom and ask.
Question. We've covered 2 really nice tools, and then Dave's going to cover one tomorrow. What types of reasons would make me pick one versus another?
Well, I'm totally biased, but I can tell you that you might want to choose one because of better support for various operating systems, different amounts of free stuff for various things. You might want to choose for certain features, like some of the things I suggested for CircleCI, like being able to log into the box or having Docker layer caching. But other systems have advantages too. Olaf?
Yeah, I mean, having seen your presentation, I'm thinking to try out CircleCI for some things. So, like, one main difference with GitHub is like, it is like just all the different ways that you could trigger jobs. Like, I'm not sure, I don't know with CircleCI, like, can I trigger a job just by commenting on an issue? Like that kind of thing.
So CircleCI has many different ways to trigger things. It has a fully functional API. Everything I showed you in the GUI, you can do via an API. So you can trigger jobs any which way you want, including, you know, having a GitHub action that would trigger CircleCI. So anything you can do in one, you can do the other. In fact, there's nothing stopping you to all 3 of these plugging them one into the other to get exactly what you need. Okay.
Yeah, I mean, like the GitHub workflows, they're kind of easy to get up and running with, and having all the configuration there. The one thing actually that I'm interested in with CircleCI is that for MetaCPAN, we're building some Docker images on the API, and it looks like we're running out of resources and things just get canceled. And that's really hard to troubleshoot. So I was thinking we will try that on CircleCI and then SSH in and see what's happening. So that's one thing.
Awesome, thank you.
Anyone else?
I've got a question. Has there been any thoughts about trying to integrate this with CPAN testers? So anytime I tag something, it can just automatically do the whole test on a bunch of things and upload it to CPAN testers, and any sort of groundwork laid for that yet?
Nico, did you actually want to say anything about that, or is that?
I can say something. For me, they are very different and complementary tool. One is testing before you release, the other is giving you feedback after you have released. So cpan tester helps you understand issues experienced by your final users, whereas the continuous integration helps you improve your development and prepare for the next release.
Yeah, the idea basically being that you could perhaps possibly seed cpan testers with a couple of tests ahead of time saying, hey, it looks this new release works on this one and works on this one.
Yeah, I wonder, like there are things you could trigger on GitHub too, like as a release, like you can watch for new tags and things like that. So you could find some way of integrating that with some of the smokers on cpan, I guess. Or I suppose maybe you could set up some VMs on, like, just use GitHub as a smoker as well, I guess. But that might defeat the purpose. Yeah.
Yeah, we've seen that basically these tools are as powerful as you want to make them. So there's no reason you couldn't submit, say, a cpan testers report from one of these as you're running, especially if you're running somebody else's, especially if you're building somebody else's code as you're building something you're depending on. There's a definite feedback loop there.
Yeah, I guess if you want to put the time into it, there's probably nothing that would stop you from uploading the pause, after you push a tag to your repo or something like that.
Yeah, in fact, for CircleCI, for one of my modules, I have that. Right, when I'm done, it automatically uploads it to pause.
Nice. There's no org for that though.
No. There's baby steps to make everything as powerful as for most people and simple for most people.
Yeah.